Hello, welcome to this short video. I want to introduce to you my seminars, and in particular BIMS1, and that is the one devoted to injection molding. The actual title is Understanding Injection Molding of Thermoplastics. I will show you a few of the initial slides just to give you a flavor of the course, hoping that this will trigger some interest on your side in order to join us in future public sessions, or if you're interested in private sessions or future online courses, these would be other opportunities. So BIMS is the name of my company, BIMS Seminars. It was created 20 years ago exactly. BIMS stands for Brussels Injection Molding Sessions. When I created this, I'm based in Belgium, by the way, I really thought I would just do these trainings in Brussels and, get people from abroad. It turned out that I only made a couple of sessions in Belgium, and then I'm mostly traveling and doing sessions abroad with a strong focus on Denmark, which has been historically my biggest customer, with over 50% of the business, roughly 50% in Denmark. Over the last 20 years, I gave the BIMS1 seminar 129 times, and there is a second seminar, BIMS2, which has been around for only about 5-6 years, and that is on mechanical properties. But the focus today is really on the injection molding seminar. So let's switch on the slides. You see here the title slide, the subtitle, The Key to Optimum Plastic Part Design. So really the philosophy of this training, which by the way lasts 2 days, so there's about 10 hours of course, plus plenty of time for questions and interactions. The philosophy of these seminars is very clearly focused on understanding the physics behind the process. The reason I started this is because I was working for a big company. I was in charge of simulations using MoldFlow at that time, and I was visiting customers, or getting customers visiting me to listen to my MoldFlow reports, and I realized that most of the people would not completely understand what I was talking about when mentioning shear rates, shear stress, or shear thinning, pressure dependence of viscosity, limitations of simulation, etc. So I really realized that, to be impactful with simulation, you have to make sure the people you're talking to understand what you're talking about. And the issue was not simulation. Of course, simulation has limitations that you should be aware of, and I mentioned most of them in this course. But really, the main issue is the physics of the injection molding process. If you don't understand the process itself, it's extremely difficult to extract value from simulation. So the course is really focusing on understanding the why. So I always say this is not about know-how. There's a lot of know-how. You can find stuff everywhere on internet. Material suppliers have very nice brochures, and you can find textbooks, you can find data sheets. So there's too much information out there when it comes to know-how. How does polystyrene behave? How does PVC behave? How does nylon behave? How much do you need to dry this material, etc. But there's very little information about the know-why. I mean, you can find answers to simple questions. Should I use this temperature or that temperature? But if you don't know why, it's very hard to apply to a new project or a new material, a new part. And so the focus of this seminar is to make sure you understand why things happen the way they do in injection molding. And this will allow you to develop the skills and knowledge to attack your next project. Okay, let's quickly browse through some of these slides. So the content is really the entire injection molding process. I spent a couple of hours initially to introduce some of the thermal aspects of this process, the rheological aspects, with strong focus on the importance of temperature, shear rate, and pressure on viscosity. Pressure is one very interesting aspect. It was completely unknown 10 years ago, and in the last years a lot of people have been, have brought up this issue of pressure dependence of viscosity. But there's still a lot of misunderstanding and, relatively poor information around, and I have a few slides really focusing on why is viscosity pressure dependent and what are the consequences. Just to mention one of interest, it does happen sometime when you mold amorphous materials like polycarbonates to observe that the part weight may actually decrease when increasing packing pressure. Now that is something crazy apparently, but it has to do with pressure dependence of the viscosity. Not many people realize that you can literally freeze a polymer by applying high pressure without cooling. At constant temperature you can freeze polycarbonate if you push the pressure high enough. Now this also has implication on the thickness of the frozen skin, which is something I'll go through in this course. So as you see here, the content is really starting from the basics and going into all the possible aspects. The end of the seminar is about residual stresses, shrinkage and warpage, and some, I think, interesting aspects of corner effect, corner deformation, which is also largely misunderstood by a lot of people. Okay, I have introduced myself, but I'm a physicist. I work for a large material supplier. I will retire this year and focus on my training seminars and consultancy from 6 months from now. My background is rheology, flow analysis, mechanical properties of polymers. Now, let me skip some of this stuff. You have here some information about the latest seminars, a few known customers there. Let me quickly go to this slide. So, as you know, we start the process essentially by throwing some pellets in the hopper here. Let's say we're molding CDs, good old-fashioned CDs. So this is polycarbonate. We start with pellets pretty much at room temperature. We melt the polycarbonate in the screw and barrel system, what we call the injection unit, and we probably melt it at around 300 C. We push it into the mold, get these parts done, and we push them out, we eject them, and back at room temperature. Now, this can be as fast as about 3 seconds. That's a cycle time for a CD. You would not gate it from the side as shown here, but just an example. So it's a super fast process, and we go from room temperature to 300 back to room temperature within seconds. So it's amazingly fast. We call this a transient problem. So very different from extrusion, that is almost steady state. The melt is at 200, the die is at 200. The pipe that comes out is still at 200 for a long time until you put it in a bath, in a cooling bath. So it's really very different from extrusion. It is also different because we need a very high pressure for this. Now, why do we need a very high pressure in this process? Well, because these are cooling lines, so the molds are cold. Now, they might be hotter than room temperature, but they're still very cold compared to the melting temperature or the softening point. If this is polycarbonate, the mold might be 60 degrees. But polycarbonate solidifies it, at 140 degrees roughly. That's the TG of polycarbonate. So we do something crazy, really. We try to fill a cold mold. And we have to do it fast, because if we go slow, the material will freeze before we reach the end of the flow, before we can actually fill the cavity. So it's fundamentally a bit of a crazy approach that is forcing us to go very fast. Now, to go fast, we need a lot of pressure. Plus, we tend to use this process only for very thin parts. What do I mean by very thin? Well, from 0.5 millimeter to a couple of millimeters, sometimes 3 or 4. But you don't want to mold a 10 millimeter thick part. Why? Well, because the cooling time or the cycle time can be estimated by taking roughly 3 times the square of the thickness. If you put the thickness in millimeters, you end up with your time in seconds. So 1 millimeter takes about 3 seconds to mold, but 10 millimeters would take 300. 10 square times 3. That is 5 minutes. Now, 5 minutes is extremely long. You would be making 12 parts per hour. That is not acceptable in terms of machine cost. So we have to focus on thin parts for this process. And of course, if the cavity is thin, pushing a very viscous material through such a thin cavity is extremely challenging. So we do have very high pressure as a consequence. Okay, pressure is extremely high. That would be as high as 200 megapascals, which is 2000 bar, more classical units that we may relate to in the shop floor level. Okay, so we need to be careful with that. What happens to a molten polymer when you apply such a huge pressure? That's one particular aspect I will go through in this seminar. But viscosity is also special for polymers. It's not only pressure dependent, but shear rate dependent. So when you fill faster, the viscosity drops to some extent, and it doesn't drop nearly as much for polymer A as it does for polymer B. And so we need to understand some of the physics so that the day you start dealing with a new polymer, you already have a pretty good idea of what may happen, what may go wrong, or if something goes wrong, you should be able to understand what's going on. Okay, I don't want to spend much more time. take much more of your time. I just want to reassure everybody that although the ambition and the goal of this seminar is to go very deep into the complexity of the physics, making sure we do not miss any of the important effects relevant to this process. My ambition is also to do this in a very easy to understand way, meaning I will not use any mathematical formulation except to define viscosity. There's one single slide with a little formula. I'll take the time to explain that, but the rest of the seminar, that is more than 250 slides, goes very deep, but you don't need to have a PhD or a formal school training. Anybody can understand what I will explain, whether you're a professor, a scientist, a mechanical designer, machine setter, or even just a commercial guy who wants to know a little bit more about injection molding. So I won't go any further through the slides. I hope with this short presentation you at least had a feeling of the style of the course. I will be writing and drawing stuff on the screen all the time. So you really get a lot of additional information compared to the original slides themselves. I hope this video will also convince you that I try to speak decent English at slow pace so that anybody can understand what I'm saying. I know, at least originally, a lot of people have been scared of attending my seminars just because maybe they're not super fluent in English. Well, English is my third language. I'm born Italian and I speak French at home, so English is the third language. And although I speak good English, I perfectly understand that if English is not your native language, I have to be careful the way I speak to make sure everybody can follow. And I definitely do that all the time. So thank you for listening to me for, I guess, in excess of 15 minutes. I hope to see you soon at one of my public sessions. I am doing this essentially by request from my friend at ATV. We hope to be able to hold a session as scheduled later this year. We're in 2020. But no matter what, even if we have to push it down a little bit, I'll be very happy to welcome you to our public sessions. If you're interested in private sessions, if you want to join us in Germany or France, we also have partners there. Sympatech is organizing the seminars in those countries. And I'm coming up soon with online versions of the course as well. See you soon.